All right, 9.3 area. So a lot of this is review, but we're going to do some fancy algebra stuff with it. So for starters, we need to know that the area is pi r squared, and the circumference, I think we're going to have to use that formula in here. Circumference is 2 pi r, or you could substitute in 2r for pi diameter. Either one is good with me. Remember that the diameter is 2 times the radius, or you could say, well, the radius is the diameter over 2. All of these we're going to be leaving in terms of pi, which means we're going to leave the pi as like a variable. We're going to treat it like a variable for all these problems. So number one, this should be really, really easy for you. Area is pi r squared. R is 10, so pi 10 squared, so 100 pi. And our units are inches squared. And that's the way that CUDA will list it as well. By leaving the pi in there, say we were actually doing like contract work in real life or something, and we were finding the area of some circle somewhere. By leaving the pi there, we are telling the engineers who would end up making the whatever the physical thing or whatever it would be, that they can decide how precise they need to be, right? If the architect or the math person who ends up modeling it for them rounds somewhere, then the engineer, I mean, they can't get any more precise. So if we were to round to the 10th, like say I were to plug in 100 pi and I get, well, 314, say we round to 0.2. Well, say they have a device that is correct to the nearest thousandth, and they really want 314.159. They really would prefer us to leave it like that. By leaving it in terms of pi, we let them make that decision, right? There's always the joke that like the math people are always precise and the engineers just round. The engineers say that pi is 3, while the math people say 3 point whatever. I don't know, that was a joke that I've always heard. But we're going to be leaving the pi in there. That way, whoever ends up messing with our problem afterwards can decide, well, I really only need it to be rounded this much, or I need it to be rounded to the nearest 20 decimal points, or whatever it is. They get to make that decision. All right, number 2. My diameter is 8. My radius is 4. So I'm going to say, well, pi 4 squared, so 16 pi meters squared. All right, number 3. This one just tells us my radius is 4. So that's actually the same thing as number 2. So pi 4 squared, 16 pi meters squared. Number 4, my radius is 7. So we should see pretty quickly that, well, it's going to be 7 squared pi, or we could say pi 7 squared. And that'll be 49 pi kilometers squared. Right, hopefully not too crazy. Number 5, my diameter is 20, so my radius is 10. So I'm going to say, well, I've got pi 10 squared, so 100 pi kilometers squared. Number 6, my diameter is 4, so my radius is going to be 2. So it's going to be pi 2 squared, or 4 pi, and my units are inches squared. Right? We're talking about area, so our units are squared. Number 7 and 8, these are the only ones that should be relatively, I don't know, interesting, longer, difficult. I don't know what the word is there. We're going to have to first start off by plugging in and getting our radius. So I know that circumference is 2 pi r. So I can say, well, 14 pi is 2 pi r. My pi's can cancel. Say I divide by pi on both sides. And then I divide by 2 on both sides. And I get, well, 7 is r. So now I can find my area. I say, well, area is pi 7 squared, 49 pi, and our units are meters squared. Yep. Number 8, our circumference is 18 pi, so I'm going to say, well, 18 pi is 2 pi r, right? Circumference. My pi's cancel, and I divide by 2, so really I'm dividing by like 2 pi here, and I get 9 is r. So my area is pi 9 squared, so 81 pi, and we're talking about meters squared. All right, so I know I went kind of quickly through numbers 1 through 6, and I guess I went quickly through numbers 7 and 8, but I'm thinking that this should be pretty easy for us. So, all right,